is this favorited? Yo, what's going on, overdue? Overdue. Walk in the room. Hey, we're at 3200. Look at that. Let's go. 3200 in the building. Nice. That's good. That's awesome. Super stoked on that. Feels good. Okay. All right, let's get some tunes going. All right. Why am I not getting in there? There we go. No, I am. Doing good, doing good. We worked on our chemical matrix program script at work today. We had some time to actually program at work, so it feels good being a little dev at work here. I just wish I had some other people that knew what they were doing in terms of development as well, that I could like ping pong ideas off of. That must be so nice. Like if you're like actively like working on like a project, to be able to just like go over to your neighbor who also is experienced in like coding or whatever, be like, yo, what do you think about this? Do you have any ideas? And like you can just go and ask around and then gather a bunch of data from your peers. And like I wonder, like, do a lot of people that are in industry, is that a common practice that you guys notice? All right, welcome back in, everybody. I hope you are having a good day today. So today's gonna be a fun one. We're going to be jumping back into MIT OpenCourseWare. We're going to be jumping into the MIT 6.002 Introduction to Computational Thinking and Data Science course today. The, like I said, MIT 6.002. We are on problem set 3 here in week 8 of the course. We've been on week 8 for like 3 weeks now because I just haven't finished this problem set assignment. It's not like, honestly, it's not a very hard assignment. It's just kind of lengthy and it's kind of annoying. Like, yeah, so it's honestly the reality of it. So I'm hoping to code today for maybe like an hour, maximum an hour and a half. We did a long session yesterday working on our project. Birdie Rose Close, the webpage, full stack website with React, Tailwind, and Python. Whereas today we're going to be doing some MIT work, maybe doing like, if we finish early, we can react to some videos. I've been watching a lot of like hacker documentary videos. I've been really into it lately. So it'd be kind of fun to watch some of those with you guys today, I think. What do you guys think? And you guys into those hacker documentaries about like 15-year-olds that just like hacked $25 million worth of something? And is that one of you guys out there? If it is, throw me some coin. All right, let's get into today. So problem 3, let me go ahead and actually pin a chat here. Today we are working on MIT 6.002 PSET 3. This is week 8 of the course. Let's pin that bad boy. Hacker kids are crack. Yeah, dude, that's what I'm saying. I feel like honestly like pretty like a little bit discouraged watching them. Like I feel a little bit motivated, but I feel a little discouraged because I'm like, dude, these like 15-year-olds are like taking down huge systems and like I'm over here trying to learn about for loops. It's like, bro, like come on, like, it doesn't make sense. But maybe they started programming when they were like 8 years old. So really they were programming for like 7 years or whatever, 5, 7 years. We've only been doing it for a year and a half. So, in relation, I don't know. All right. Cool. Let's get into today, you guys. Welcome in. If you guys are part of the early crew, feel free to leave a like on that stream if you would. I really appreciate it. It's completely free. So if you could do that for me, just to help us out, to keep our channel growing here. We're at 3,200 subscribers, so thank you guys truly so much. Keep an eye out on the Discord over the next day or two. I'm going to be dropping the first series of the giveaways of the skins we unboxed in Counter-Strike. So if you have a Steam account, play Counter-Strike, or even just have a Steam account, you can accept trades even without even playing the game, I think, right? I'm not sure. I think so. Consider joining the Discord down below and getting access to the giveaway. I'm trying to figure out how to do it. Okay, let's get into MIT today. Okay, problem 3, standard robot and simulating a time step. Each robot must also have some code that tells it how to move about a room, which will go in a method called update and position and clean. Right here. Ordinarily, we would consider putting all the robots' methods in a single class. However, later in this problem set, we'll consider robots with alternate movement strategies to be implemented as different classes with the same interface. These classes will have different implementations of the update and position and clean function, but are for the most part the same as the original robots. We will again make use of inheritance to reduce the amount of duplicated code. We have already refactored the robot code for you into 2 classes. The abstract robot class you completed above, which contains a general robot code, and a standard robot class inheriting from it, which contains its own movement strategy. Right, hold on, let me read that one time. We have already refactored the robot code for you into 2 classes. Abstract robot class, where the robot class? Here. Which we implemented. Okay. Then we have a standard robot which inherits and a faulty robot which inherits. Okay. And a standard robot class inheriting from it which contains its own movement strategy. The movement strategy for standard robot is as follows. It's hot in here, my guys. Gotta open up this window. Maybe crack the fan for a sec. Ooh. Okay. The movement strategy for standard robot is as follows. Each time you take each time step, calculate what the new position for the robot would be if it moves straight in its current direction at its given speed. Bullet point 2. If that is a valid position, move there and clean the tile corresponding to that position by the robot's capacity. The position is valid if it is in the room and if it is furnished. However, do not worry about the robot's path in between the old position and the new position, and whether there is furniture in that path. Otherwise, rotate the robot to be pointing in a random new direction, don't clean the current tile, or move to a different tile. We have provided the getNewPosition method of the position class, which you may find helpful in implementing this. It computes and returns the new position for the current position object after a single clock tick has passed with the given angle and speed parameters. Read the docstring for this method for more information. Our goal here is to complete the update, position, and clean method for the standard robot class to simulate the motion of the robot during a single time step, as described above in the time step dynamics. Okay. Let's go ahead and see here. So we have this position class, right? Which gets new position given an angle and a speed. So you compute an old x and old y, getting self.get x and y of this class. And then you calculate a difference in x and y by taking a speed and multiplying the math sign and cosine of the angle. And then you add that to the existing position. And then you have a new position here. Okay. So the robot class, sorry. A standard robot is a robot with a standard movement strategy. At each time step, a standard robot attempts to move in its current direction. When it would hit a wall or furniture, it instead chooses a new direction randomly. Simulate the raised passage of a single time step. Move the robot to a new random position if the new position is valid. Rotate once to a new random direction and stay stationary. What? Move the robot to a new random position if the new position is invalid. Rotate once to a new random direction and stay stationary. And clean the dirt on the tile by its given capacity. Okay. Okay, so we need to simulate the raised passage of a single time step. We have provided the getNewPosition method of the position class, which you may find helpful. It computes and returns a new position. Okay, so we have a robot, right? So robot itself has position, a current position, a direction, which is an angle, a speed, and a capacity. Okay. So if that's the case, then let's do this. So we would do, so we have a current position, which is self.position, right, in robot. And we're inheriting from robot. So we need to update, position, and clean. So simulate the raised passage of a single time step. So move the robot to a new random position, then invalid to a new random position. If the position is invalid, rotate once. So we need to simulate movement of this robot. So robot get robot direction, get robot set robot position, not implement, right, set robot direction, update position and clean. not. Later, overdue. See ya, dude. Okay, so we need to calculate what the new position will be straight in its current direction. So its new direction, so its direction is an angle. And we get new position based on that angle. Yeah, okay. All right, I think I know what to do. I'm not sure, we'll find out. We'll find out, that's for sure. Okay, so here we're going to new position is equal to a position object. And we're going to put in oh my gosh, maybe not. Get X and get Y. Get new position. Okay. No. This is what we're gonna do. So we're gonna new position is gonna be self.position.get new position, right? Given self.direction as the angle and self.speed as here, but we'll say self.get robot direction, and we'll say get robot speed to use inheritance, right? Or we'll say yeah, wait, so self.position, I can even, so I can say self.get position. Right, let's do this. So let's just say get robot position. So this is current position. Right? We don't really need to do this, but because we can just reference the self itself, but they have these here and they want us to use inheritance, so we'll try. So current position is self.get robot position. Now we're going to say new position is equal to is equal to the current position dot get new position, and we're going to put in here self dot get robot direction, which is the angle, right? Because you have this robot object which has a get robot direction and set robot direction, right? So in the robot, yo Tim, where you been, my guy? So current position equals this, and then we say get new position self dot get robot direction on the new position, right? And then the self dot, this is the speed, self dot speed, right? So we would say if new position, the thing is we're not passing in this room. Right, the robot isn't getting a reference of the room. Oh yeah, it is. Let's go. So in the room object that's being passed in, we have clean tile at position, is tile cleaned, get number of team class, is position in room, right? So we'd go here to our robot. So if new position, if self.room, this is the robot, and a robot has a room object, right? No. A position is given X and Y, rectangular room, a robot has a room on its initialization, but I'm not saving it, so I need to say self.room goes to room. So I need to capture this room as reference, so I can say if self.room is is position in room. So if I go here and say self.room, let me just quickly make some type hints so it can give it to me. Robot, where are you? There you are. Room is going to be a room, rectangular room. So then if we go back here, so is position in room, which is valid for this room now, we're going to provide it a position of new position, right? So move the robot to a new random position. If the robot's new position is valid, right? If it's invalid, rotate once in a random direction. So if it's in, so if not position in room, then what we're going to do is say random direction is equal to, are we saying to a new random position? So if we have position is get new position, hang on, speed, rectangular room, clean tile, is tile clean, get number, is position room, get dirt amount, get number, is position valid. No, it's not that one. Get random position. So do not change implemented in subclass of empty room here. Get random position. So this will return a random position in here and determine if, right? Okay. Is position valid if it's in the room? Okay. So we'll say is position valid given new position. If it's not, random rand position, right, is equal to a self.room dot get random position, right? If the new position is invalid, rotate once to a new random direction and stay stationary. Oh, hold on. Move the robot to a new random position if the new position... what? So we want to move the robot to a new random position. If the new position is invalid, rotate once to a new direction and stay stationary. I think this doc string is a little bit bad. It's supposed to be calculate what the new position for the robot would be if moved straight into its current direction and speed. So we current position, we get a new position given the current position, and we give it the direction and the speed, and we determine if that position is in the room. If it is not, then we need to not get a new random position, right? Empty room just gets a new random value between the height and width, right? So we need to get a new direction. So we'll say set robot direction. Right. And we're going to use a random uniform, this guy. So if we say, we don't want to get random position, we say room, the self dot direction, no, random direction is equal to self dot, no, just random uniform in this, right? 0 and 360. And then we're going to rotate once to a random new direction and stay stationary. And clean the dirt on the tile by its given capacity. So this is random direction, and we're going to say self.direction, self.set robot direction given the random direction. And then what we're going to do is we set a new direction, then we need to clean. So the robot itself has a update position and clean, which is empty. Has a capacity, and we have a current position, which position has X and Y values. So we would say room we would use the room, right? And we would say get dirt amount clean tile at position, right, on this room. Okay. So now let's go ahead and do self.clean, room clean tile at position given a position of self dot well, hold on, new position. Attempt position, attempted, right? If the attempted position if it's not in the attempted, if the it's not in the room, then we're going to get a new direction, set the direction, and clean the current tile. So on the current room, we're going to say self dot get robot position, and then the capacity given is self dot capacity. So let's say get the current position of the robot. This is attempt to move the robot to a new position in the current facing direction, right? If attempted position not in the room, then we're going to get a new random direction and assign to the robot and clean current tile, right? And then so calculate what new position the robot would be if moved straight at its new direction. Boom. If that position is valid, move there and then clean the corresponding tile. So we will clean no matter what. So what we're going to do is say if it is valid, then we're going to self.set robot position to that attempted position. Right? And this would have to have an else statement. Right? And so no matter what, we clean at the current time. So if that position is valid, move there and then clean the tile corresponding to that position by the robot's capacity. If the position is valid, if it is in the room and if it is unfurnished. So, and if it's unfurnished. Okay, so we'll say if it's not in here, right? If it's not even in the room, then we don't even need to do anything with it, right? We'll get any direction. Else, elif, so is this a furnished for the standard robot, given the room? So is tile furnished, given the current room? Is position furnished? Is position valid? So obviously, so this is not an empty room, but they do use it with an empty room. The position is valid if it's in the room and if it's unfurnished. Well, the empty room object doesn't have that method, right? An empty room like the method might not exist, you know what I mean, you guys? No worries, Tim. Yeah, we were up late last night. Don't worry about the robot's path in between the old position and the new position and whether there is a furniture in that path. So this doc string does not match the requirements here. Because this doc string wants me to clean dirt on the tile by its given capacity and move it to a new random position in standard robot, but that's not the implementation of standard robot here. Huh. Say this. Come on. The heck? Get them zoomed in. Oh. Say, this is my movement strat for the MIT 6002 pset 3 prob 3, but the doc string has diff information. You spotted that your doc string and indeed and your intended strategy don't match. The problem set redefined two robot subclasses with slightly different behaviors. The doc string you pasted is for the standard robot random walk, not the random walk robot. Keep direction until invalid. What your movement strategy is? Try moving straight until. So is there a different robot then? No. Try moving straight ahead in the current direction at speed. If the new position is valid inside the room, move there and clean that tile by capacity. That's what my movement strategy says. It says calculate what new position would be if you move straight, right? If that position, move there and clean the tile corresponding to the position. Oh, okay. So we would say we want to calculate what the new position for the robot would be if we move straight. So that's what we're doing here. If that position is valid, okay, if it's valid, move there and clean the tile corresponding to the position by the robot's capacity. So if it is, then we're going to clean here, right? position is valid if it's in the room and if it's unfurnished. It's wanting me to check both valid positions and in room and non-furnished, but it's using both classes of empty room and furnished room in the testing. Oh, so you just used a specific one that we overwrote. So room.isPosition valid. Depending on whatever room it is. So if it is in the empty room, isPosition valid will return if it's just in the room. And then if it's in the room for a furnished room, then it will check if it's also furnished. Okay, so that's okay. So then we just overrided that function. Okay, so then we say that'll handle both those cases and non-furnished, right? If it's not in the room or it's furnished, then we get a new random direction to assign the robot. Okay, so then we say if that's valid, move there and clean there. So else we set the robot position and clean. Otherwise, rotate the robot to point in the new random direction. Don't clean the current tile or move to a different tile. So then this is my function here, I think. Okay, this is my function then. My docstring is valid. Just move the cleaning cell outside. Oh, it just wants to always clean. But in this one, it doesn't. Do not clean the current tile. Yeah. So this is incorrect. This doesn't match. This is does not say at warning. Warning. Doc string does not match the PDF prob 3 instructions. Right. See PDF for implementation details. I guess I could do this. just need to copy this last sentence. Otherwise, move the tile. Okay, so yes, that's what you've written now is basically the correct standard robot notation, except for one small thing in your comment line. Yeah, we don't want to get a new random drawing. Yeah, we don't want to and clean new robot. Current position is get position, attempted position. If it's in the room, then we're going to set it to the robot position and clean that tile. Clean the current title of that new position. Else, we're not going to do it because you're cleaning if it's on valid. So you will run this in a loop and clean once you deem valid. So you don't need to clean again. I guess it makes sense because when you reach a new position that's valid, you clean on that finding. You don't clean after the fact once you find an invalid position, clean the previous. No, you would clean the next sequentially. So I guess it makes sense, right? Hey, thank you for the raid here. Your Sky. Yeah, thank you, dude. Appreciate you so much. Welcome. We're doing MIT Open Courseware 6.002, the Introduction to Computational Thinking and Data Science course. We've been taking this course independently on the stream here. We are on week 8 or problem set 3. We're on problem 3 of it. We're wrapping up problem 3 here. So exactly, we've got it. For standard robot, the cleaning is tied to a successful move. Thinking of robot as probing for each time step. If you move on to a valid tile, then clean that tile. The step is invalid, it just pivots to a new direction next time. No cleaning happens because it never arrived on the new tile. Whoa! It's not a random walk robot. So let's uncomment this out, and will this run? I don't think so. No, because I think we're importing that, yeah. And we know that function is not very, it doesn't work. Or this import file is like an old version of Python, so we can't really test our code, but it's okay. Okay, so testing your code. Before moving on to problem set 4, check your implementation of standard robot works by uncommenting the code line on your implementation of standard robot. Do this. This will test if your robot moves correctly in an empty room. Hey, thank you for the sub. Let me see who that was. CJ Mammoth and Eurus Guy. Thanks so much for the follow on Twitch and the sub on YouTube. I appreciate you so much. 07. What's 07? What's up, Glitch? How's it going? First 6. Got a degree in human biology and a minor in chemistry. I've been teaching myself how to code every single day almost for the past year and a half. Doing courses like MIT Open Courseware, Harvard CS50, reading books, Introduction to Algorithms by CLRS, Data Structures and Algorithms in Python, Fluent Python, Python Crash Course, and more. Building a full stack business site right now on my off days on stream when I'm not doing learning. But yeah. Okay, so we can't really test this, unfortunately, because the old version of Python, this was written on an older version of Python. It's not really that prevalent to figure that out and make sure get it to run and stuff. It kind of is beside the point. As long as we kind of get the meat of what we're doing here and understand the code we've written, or wrote, then that's what's important here. So for this standard robot class for problem 3, we inherit from robot and we're creating a standard robot. So we are going to override the update position and clean method that's in robot, right? That's just currently not implemented. And we're going to inherit all the other attributes and methods thereof. Within this method, we are going to get the current position of the robot using the self.getRobot position, which is inherited from robot. We are going to attempt a new position, which is going to get a new position based on the current, given the current direction we're facing and the speed that we are currently at. Right? If that position is not valid, then we're going to assign a new random direction to our robot. Okay? And then just kind of wait to do this call again. Or like we'll probably like break. It'll just break, and then it'll get called again to clean a new position, right? Facing that new direction, right? You kind of just go until all the tiles are clean, or until you run out of battery, or until you have maximum capacity, or whatever. Now, else you set the robot position to that attempted position that was successful, and then you clean that attempted position that was successful. And then you attempt another position after that, and if that's valid, then you clean that one. If it's not valid, you rotate and wait for the call again. Right? Cool. Hey! Oh, it's a salute. That's cool. I didn't know that. I like that. Hey, Aaron. Thanks so much for joining me, dude. Appreciate you so much. You're awesome. Thanks so much for the follow here. Okay, let's check out problem set 4 here, or problem 4. We'll code for another half hour or so. Oh no! It turns out iRobot churned out a bad batch of robots. Due to a problem with their vacuums, these robots randomly forget to clean a tile and will change direction. You have been asked to design a simulation to determine how badly this affects the time it takes a robot to clean a room. I wonder what kind of like bugs they face at iRobot. Like what do they have to fix on a daily basis? You have been asked to design a simulation to determine how badly this affects the time it takes a robot to clean a room. Faultiness is determined for each time step. If a robot is faulty at one time step, it may not be faulty at the next time step. Okay. Write a new class, faulty robot that inherits from robot, just as standard robot inherits. But implement a new movement strategy for faulty robot, where faulty robot should have its own implementation of update position and clean to do the following. Number 1. Okay, so we have this faulty robot. It's a robot that will not clean the tile it moves to. A faulty robot is a robot that will not clean the tile it moves to and pick a new random direction for itself with probability P rather than cleaning the tile it moves to. So we have a probability of 15%. And we're going to we have a set probability, which just sets this, okay. We have get faulty, which answers the question, does this faulty robot get faulty at this time step? So we return a random probability a true or not that we are faulty less than the probability. Okay. And then this will just return a Boolean true or false if this value is less than the probability that it happens to be faulty. And then we have an update position clean, which is not implemented. So this simulates the passage of a single time step. It check if the robot gets faulty. If the robot gets faulty, and do not clean the current tile and change its direction randomly. If the robot does not get faulty, the robot should behave like a standard robot at the time step, checking if it can move to a new position. Move there if it can. Pick a new direction. Okay. This isn't that hard. Depends on whether or not Will Smith will be there. What? Okay. Stretch it out. Okay, so check if the robot gets faulty. Okay, so if self.get faulty, right? So this robot has a position. So we say if this robot is faulty at this time step, then if it is faulty, do not clean the current tile and change its direction randomly. So say self.update set robot direction to what we had before. We'll say rand direction is equal to random dot rand uniform 0 to 360. Right? We then set robot direction, giving this random direction. Okay. Okay. We will then and change its direction randomly. Okay. If it is not else, it's not faulty. The robot should behave like standard robot at the step. It should check if it can move to a new position. So we'll say, we're just going to take current position, new position. Can I call? No, because this calls self, which looks for this class. So we would want to say current position is equals to self.get robot position. Attempt position is equal to current position dot get new position, self dot get robot direction, and self dot speed. If self dot room dot is position valid, attempt position, right? Yeah. If it's valid, or if not valid, right? If it's not valid, so if it is valid, we'll just say if it is valid, then what we're going to do is move there. So self.set robot position to attempted position, and then self dot clean room dot clean tile at position giving position. We get robot position then, and this will be self dot capacity. Right. So that'll handle that. So then if it cannot happen, we need to pick a new direction and stay there. So let's just go like this. Let's just get a random direction out front. And we'll set that if it's faulty. Else what we'll do is we'll say else here. If it's not valid, then we'll say self dot set robot direction to the random. Okay, so check if the robot is faulty. So we get a random uniform direction no matter what. If it's faulty, we set that direction right there and do not clean. Okay. If the robot does not get faulty, else, the robot should behave like the standard robot at this step, checking if it can move to a new position. If it's valid, then we will move there if it can. Like the standard robot, clean if you can. Pick a new direction and stay stationary if you can't. Okay, so this is my faulty robot then. Oop. Okay, I wrote the next problem for faulty robot. Nice, your implementation of faulty robot looks solid. Let's walk through it carefully. Class variable has a shared variable that's correct. Get faulty, right, is a way to simulate this trial. Update position clean. If faulty, you do not clean. You set a new random direction. If it's not faulty, you basically copy the behavior of the standard robot. Things to double check. Right now, direction update when faulty. Right now, you do this. Direction update if faulty. That works, but technically the robot is faulty. If the robot is faulty this step, it's supposed to just stand there, not move, and pick a new random direction. You've got that right since you do not change position. Okay. Direction update when blocked, non-faulty. Matches the standard robot logic. If you want to make it a little cleaner, you could reuse super update position and clean from the standard robot in the else branch. But I'm not inheriting from standard robot. I'm inheriting from robot. So what I could do, right, instead of rewriting this entire function again, which is very similar to this previous function here, right, is I could have faulty robot inherit from standard robot, and then I could call super on. Oh my, that was freaked me out. The kitty's right here. She was scratching herself and hitting the window. I was like, what in the world is that noise? Kitty. And so but this was written, this problem was made, I believe, when super was not in Python yet. So you cannot super the class, and so they did not do that. But this inherits from default ABC abstract base class robot, not standard robot. So we can't super if. The faulty robot inherits directly from the abstract robot, not the standard robot. There's no parent implementation to call for the super. That's why your inline implementation standard logic is right here. So then, is this correct? I'd say your implementation is correct after the assignment is written. A faulty robot will not clean with a probability P. Picks a new random direction for itself with a probability of P. Yes. Sweet. All right. And then problem 5 here. So we'll probably do this one. This is crazy. So in this problem, you'll write code that simulates a robot cleaning the room up until a specified fraction of the room, and outputs how many times steps are needed on average to clean the room. Once you have written this code in problem 6, you'll comment on the results of your simulation. Each robot should start at a random position in the room. Each room should start with a uniform amount of dirt for each tile. When a specified fraction of the room of tile files is completely clean. Okay, we'll do this one probably next time. To wrap it up. What do you guys think? What you guys think? You have any polls here? Stream's whack, bro. We got some people. All right. Yeah, we'll do that one next time. Okay, you guys, I think I'm gonna call it for today here. A little bit of a shorter stream today, but we did do about 3 hours yesterday of just live coding, working on our project, building out some cool features, and designing the product card placards. I would like to show you guys that here. This is what I currently have for this, which is pretty cool. It's a little bit blurry here because we're zoomed in, but I have this kind of cool paper cutout custom asset that I think I'm going to also include, like on the next. I'm going to do another rendition of it and do like a piece of gum here, chewed up gum, to make it look like it's stuck to this Polaroid image. But for a sold image, we worked out the logic to detect through the props pass through of the status boolean if it is sold or not, the sold status, right? And so if it is, it gets a grayscale across its images and gets a sold flag layered over the top. And then if it's available, and then also it does not allow for the scale for hover effects. And then for available ones, you are available to get the scale and whatnot. We also implemented and found a cool little digital asset pack for these kind of Scotch tapes, which was free, which was really nice. And I made about or cut out in Photoshop about 3 of them and incorporated them. And so what I'm thinking is tomorrow or next time we work on the project, depending on when we finish the MIT stuff, is we're going to write some logic to randomly insert one of the assets from an array of Scotch tape assets. So rather than having every single picture or product placard have the same piece of tape, right? We can have about 5 or so pieces of tape within our assets package, and we can randomly choose which one to use out from the length range, right? And then we can use that asset, and so it can kind of create this kind of more of a natural feel for, rather than having every single tape look the exact same. You can have some randomness to it and make it more, just have some more feel. I think would be nice. I think it would be cool to also maybe implement an alternative style as well for some of these, where maybe sold ones get a different type of tape where they're like on the corners, and available ones don't. I'm not sure, or maybe we just make that one random as well. I think having like some tapes like taped at the corner versus just over the middle could also add some different effects. And then obviously my goal is to as well change the font over to a custom. I would like to hand write in Sharpie and make my own font using a font template, and then use that font to kind of be the font here, kind of mimicking what it would be like to have handwritten words here. So anywho, let me know if you guys have any design tips or things you'd like to also include in the Discord. Please let me know. We chat in here about what I'm doing and improvements we're making. So if you guys have any suggestions, please let me know. But anywho, this was problem 3 and problem 4 from MIT Introduction to Computational Thinking and Data Science 6.0002 through MIT Open Courseware. I appreciate you guys for being here. Thank you guys so much. In the next one, we'll finish up this problem set by wrapping up problem 5 and the little write-up problem 6, and then moving on to week 9, lecture 9. Woo! So super stoked to be making some progress and getting going. Honestly, I've just been kind of delaying because this a little bit of a tedious homework assignment. It's a 15-page PDF here, so it's pretty long. But anyways, I really appreciate you guys being here, and I'll see you guys tomorrow. Bye, guys.